So here's a flexible ARM processor here, the IDTechEx show. So hello, so who are you?
I'm Chris Flautner. I'm a VP Technology in ARM. And I just gave a keynote here on IoT and flexible electronics and the future. And one of the things we like about this stuff is that it keeps on continuing on Moore's Law beyond Moore's Law. So we've seen huge progress in plastic electronics and over the last few years. Integration densities, functionalities coming up, and we've been working with these guys here, PragmatIC, who are actually the experts at designing plastic electronics. And on this particular piece of plastic, they've put down a whole bunch of ARM microcontrollers.
This is the ARM one?
This is the ARM one, and they've also brought a whole bunch of other things that they built.
So this is the one that Sophie Wilson thought of, and Steve Ferber actually designed and everything.
No,
they have the same functionality.
Yeah, well, it's 20 years later, but yes, yeah, it's
20 or 30, right?
Yeah.
And so this is actually a Cortex-M based product. So although it has a complexity similar to the ARM one, it actually is based on the latest Cortex-M architecture of ARM.
So is it like a full 32-bit?
Yes.
M0 plus?
32-bit microprocessor system on chip. So it includes the memory as well.
So this is kind of like a parallel Moore's Law, right? Because Moore's Law in regular silicon is going in one way, and this is...
Yeah, in plastic integration densities, there is a Moore's Law. It's not Moore's Law, it's somebody else's law, but it is exponentially improving, and that's what we're seeing here. How were the previous prototypes? What was the rate of improvement in them?
So I think the first version of this we did about 2 years ago, that Mike Muller introduced at TechCon, was about 7 square centimeters, and we're now, as you can see, down to about 1 square centimeter. And actually we have a version, the next version of this is about half the size again. So we've got something in the region of a 10x reduction in footprint in the space of a couple of years.
So who are you?
So I'm Scott White, the CEO of PragmatIC. So we've been working with ARM for the last couple of years. ARM actually became an investor in PragmatIC in 2014. And we've been working on a range of projects, but in particular looking at how our technology can be applied to implement standard microprocessor architectures such as ARM has, and using that as a vehicle to really push the boundaries of the complexity and the functionality that can be implemented with our thin, flexible electronics.
So the potential here, if this works out, that this could be in the table, and the floor, and the chair, and everywhere, because it's so cheap, right?
That's right. I mean, if you look at the classic electronics industry view of the Internet of Things, it's very much focused on quite complex products like lighting or cars or homes or things like that. And we're really looking to push that to everyday objects. So the things that we interact with multiple times an hour or multiple times a minute, sort of every day of the year, how do those things have some intelligence, some understanding of their environment, and the ability to interact with each other and with the humans that are using them.
So is this a requirement to make the 100 billion or trillion ARM processors happen?
Well,
something like this is could make it happen.
Yeah, I mean that's why we're looking at this. It's one of those technologies that, if it takes off, it can be incredibly cheap. It allows you to customize your designs. You don't have to have high volume to be cost effective. It can you can integrate other logic onto this and sensing around it. So it has some of those properties that could become quite interesting. And if you can certainly build these at the few cent level, there's nothing to stop it to proliferate.
And who are you?
I'm João de Oliveira, VP Business Development. So this is an R&D project, as my colleagues mentioned. At some point in a to-be-defined future, the few square centimeters will become few square millimeters, and then it may become commercially viable and interesting to have ARM processors at 1 cent or thereabout in almost any object.
So there could be a Cortex M0 plus or something in a few square millimeter printed plastic.
At some point in the future, yes. So the cost will go down, the performance and the power budget will go down accordingly. In parallel with Moore's Law, so it is the same logic with the 30-40 years difference. Yeah.
So how is it possible to do this? How does it work?
So PragmatIC's key innovations really are in the device architectures and the processing technologies that allow us to do electronics very accurately on plastic. So we can achieve similar kinds of progression in feature size and yield and performance and so forth that silicon has done, but do that with materials on very thin film plastic. So as you can see here, this is actually our latest generation material set, which is actually less than 10 microns thick for the entire material stack. So that includes the plastic substrate, which is actually most of that, and all of the electronics, including the interconnect layers and the devices within the IC. So as you can imagine, sort of doing that on something that's that thin and flexible isn't as easy as silicon, where you have a nice rigid wafer that stays put exactly where you left it, and therefore you can align to very precise accuracy. So our key innovations really are how we pattern accurately on these kinds of materials, and in particular how we ensure very good registration between the different layers so that we can actually get very good yield, very good consistency in performance characteristics, and therefore make an integrated circuit.
So I don't want to ask too much, but I'm wondering, is it just one layer?
Nope. It's actually what's about a 10 layer.
10 layer on plastic?
Yeah.
How is that possible?
Just by a lot of hard work, really, on developing it.
Different processing steps.
You have different material layers for the semiconductor, the dielectric, the equivalent of the poly layers in a silicon stack and so forth. So there's a lot of materials innovation, obviously, in actually getting the materials right with appropriate characteristics. But then